students. Welcome back. And ladies and gentlemen, this week we are going to be focusing on more specific types of chemical reactions known as replacement reactions. And the good news is that we don't have many notes at all to take this week. The better news is we've got lots of activities we're going to be doing this week. So let's jump right into our topic this week, replacement reactions. So before we dive in, actually, let's do a quick review from last week. If you remember, we started talking about the 4 types of chemical reactions, and last week we focused on the first 2, synthesis reactions and decomposition reactions. And before we move any further, you might want to pause the video just to go back and refresh your memory as to what synthesis and decomposition reactions were all about and what their general formats were. All right, welcome back. So today we are going to be exploring the 3rd and the 4th types of chemical reactions. And so let's get into number 3 right now. 3rd type of chemical reaction is called a single replacement reaction. Now, I must say that the single replacement reactions and the 4th type of reactions we're going to be discussing this week do tend to be a little bit more, shall I say, reactive. Explosive, maybe even. Generally speaking, explosive reactions tend to be these types of reactions, which is why I've used this little cartoon here to illustrate single replacement reactions. But what exactly is happening during a single replacement reaction? You may recall again from last week, and you just reviewed them, a synthesis reaction is when 2 or more smaller things come together to form something more complex. It's like addition. Decomposition reactions is when you have something more complex breaking apart into 2 or more simpler things. Single replacement reactions, a little bit different than the 2 of them. You see, a single replacement reaction, an uncombined element replaces an element in a compound, and it's that replacement of another element that gives this type of reaction its name. Thus, single replacement. Single replacement, an uncombined element, a single element, is replacing another element that is already found in a compound. So let me give you the general format of a single replacement reaction, then I'll try and illustrate it with an analogy that perhaps will help you understand it a little bit better. So here's the general format of a single replacement reaction. Remember, these are variables. These letters are variables. These are not symbols of any particular element. But in this case, we have an uncombined element represented by the letter A, the variable A. And notice the red arrow is indicating that is replacing another element that is already bound in a compound. So in this particular general format, you'll see that the A is replacing the B. And if you follow the logical conclusion there, the products will be 2 different things. It will now be the A combined with the X instead of the B, and the B will be by itself. So make sure you write down the general format and notice what's happening here as I talk about an analogy that maybe you will be better able to understand. Are you ready? Here it goes. Let's say we've got a seemingly happy couple, Harry and Clarice. Now notice Harry and Clarice. They both have smiles on their faces. They seem very content with one another. I mean, after all, look at Clarice. She's got hearts all above her head. It seems like Harry and Clarice are happy together. But are they? Well, one day, someone else comes on the scene, and his name is Zeus. Now, check it out, ladies and gentlemen. Harry is a stick figure. Zeus, on the other hand, he's got a body and full living color. Wow. Can Harry compete with Zeus? Golly, I don't know, but check it out. Zeus is quite a specimen. And Zeus looks over at Harry and Clarice and says in his mind about Clarice, "Ooh la la, I want Clarice for my own." Now, what's the only thing standing in the way between Zeus and Clarice if Zeus wants to get together with Clarice? That's right, Harry. Now, if Zeus and Harry were to have a little physical competition, who do you think is going to win the competition between Zeus and Harry? I think the answer is probably clear. How can a stick figure possibly complete with a character with a body and color? Wow. And so Zeus wants to get together with Clarice and does just that. Zeus boots out Harry, and now Harry and Clarice are together as a couple. In fact, look at Clarice. Doesn't she look even happier? It looks like she's jumping up for joy now that she's together with Zeus. Now, I do feel badly for Harry. In fact, if you look at Harry now, Harry is rather unhappy. He no longer has a smile on his face, but I wonder if there's anything that could be done to turn that frown upside down. But notice what has taken place right now. Zeus has replaced Harry. Think about it. Think about what just happened with Harry and Clarice and Zeus. And now let's look at an example of a chemical equation, which we will be exploring in the lab later on. Here we have zinc being added to hydrochloric acid. Or could we say Zeus approaching Harry and Clarice? Let the fireworks begin, so to speak. So if zinc, or Zeus, meets up with hydrogen chloride, or hydrochloric acid, or Harry and Clarice, what do you think is going to happen, folks? That's right. Zeus is going to kick out Harry. The zinc kicks out hydrogen. It is a single element that replaces another element that is already in a compound. This single replacement, and notice the general format above it, you can see that the zinc replaces the hydrogen so that the zinc and the chlorine are now bonded together, and the hydrogen is off by itself. Or is it? What does that subscript mean? Well, before I get to that subscript, do you see what's happening? If you don't see what's happening, pause the video until you see it. An uncombined element, zinc, He's replacing another element in a compound. Notice how the zinc replaces the hydrogen, so we've got zinc chloride, and hydrogen is off by itself. It has been replaced. Notice its connection to the general format here. Okay. Now I'll get to that subscript of 2. You see, in nature, hydrogen being the smallest element on the periodic table and having only one valence electron, hydrogen is never happy when it is by itself. Hydrogen would always be more stable, more content, or happier with a filled outer energy level. Think back to the topic of atomic bonds to refresh your memory about that point. And so as a result, any free Harrys that are out there floating around, they're all unhappy Harrys. And so they realize that if they just connect with one another, they can be happy Harrys. So unhappy Harrys floating around with only one valence electron recognize that there are other unhappy Harrys floating around with one valence electron. And so in nature, Harrys always tend to hang out with other Harrys. It's called a diatomic molecule of hydrogen because when they share their valence electron, they're both happy Harrys. Unless something else happens, another chemical reaction takes place, and that's a story for another day. But do you see, the story of Zeus, Clarice, and Harry is a love triangle of chemistry, and it illustrates very easily and very clearly, I believe, a single replacement reaction. And once again, here is that reaction. I'd like you to make sure you write this down in your notes in this section. And then I'd like you to take some time to go through the 4 steps of balancing equations in order to balance this equation between zinc and hydrochloric acid. Once you have finished balancing this equation, here's what I'd like you to do with the remainder of your time. I'd like you to turn back to the last topic. And in your books on pages 135 and 136, there are 2 pages of practice chemical equations. What I'd like you to do today is this. I'd like you to look through those equations. Last week, again, we learned about synthesis and decomposition, and today, so far, we've just learned about single replacement reactions. Tomorrow, we'll get to the 4th type. But what I would like you to do next to the right-hand side of the chemical equations, I'd like you to go through them and identify what type of reactions they are. More specifically, I want you to go through the chemical equations and identify all of the synthesis reactions and write the word synthesis to the right of the chemical equation. Use last week's topic notes to help you out. Then go through the list once again, those 2 pages, and find all of the decomposition reactions. Again, notice the general formats, and put the word decomposition to the right of those equations. And then finally, for today, I'd like you to once again go through that list of equations and find any that fit the description of a single replacement reaction and write single replacement next to those reactions. If that came easily to you, then what I'd like you to do is to start working on balancing those particular equations. We'll finish that up tomorrow, but that's what I'd like you to do now after watching this video. And so until tomorrow, I'll say bye-bye.